We are going to go over inverse trig derivatives. And the first thing we need to understand is what are the formulas which do apply when you've got y is equal to sine inverse of x. Well, when you have got y is equal to sine inverse of x, this, if I take sine the other side, that is going to give us sine of y is equal to x. Now what I have here, I'm going to differentiate it. So if I differentiate sin, we know that we have got first, let me put this as sin, the x-axis, and then this as negative sin, this as cos, and then this is a negative cos. So as we go in the anti-clockwise direction, we are differentiating. So when you differentiate sin, we get cos. So the derivative for sin, that would be cos. We have got y. After we are done that, now we differentiate the angle y. So we'll just differentiate sine, maintain the angle the same way it is. After you are done, now differentiate the angle. If you differentiate y, you are going to get 1, but each time you differentiate y, you add dy over dx. And that is going to be equal to, differentiate x, that is going to give us a 1. So to remain with dy over dx, that will be 1 divided by cos y. Now from here, we know that from our identities, cosine squared of y is the same as 1 minus sine squared of y. So if I want to have only cos y, I'm going to square root both sides. So that will be square root of 1 minus sine squared of y. So that is what I'm going to substitute here. So that will be 1 over the square root of 1 minus sine squared of y. And from here I can substitute, this will be 1 over the square root of 1 minus, what is sine y squared or sine squared y? We are here. If we square both sides, I square this side, I square this side, we see that x squared is going to be equal to sine y squared. Therefore, where there is sine y squared, we're going to put x squared. So whenever we differentiate sine inverse, this is what we get. 1 divided by the square root of 1 minus x squared. Now in the same way, we're going to work out cos. Let's do that. If we have got y is equal to cosine inverse of x, if I take cos the other side, that will give us cosine of y is equal to x. So now differentiating cos, we saw that going from cos, that is going to give us so I'm differentiating from here, d over dx. That is going to give us negative sine of y. Now after we differentiate cos, we differentiate now y, that is going to give us 1. And every time we differentiate y, we add dy over dx. And differentiate x, that is going to give us a 1. So that means dy over dx, I'm going to divide both sides by negative sin y. That will be negative 1 divided by sin y. But we know that sin squared y is equal to 1 minus cos squared y. So to remain with sin y, I'm going to square root both sides. And so that will give me negative 1. Where there is sin y, I'll put the square root of 1 minus cos squared y. But what is cos y? Cos y is equal to x, but because it is squared, that means it is going to be x squared. So this will be negative 1 over the square root of 1 minus x squared. So this is every time we differentiate cosine inverse of x, this is what we get. Let's consider also tan. If we have got y is equal to tan inverse of x, if I take tan the other side, that becomes tan of y is equal to x. Now I'm going to differentiate this one, d over dx. What is the derivative for tan? Well, from our trig derivatives, we know that if we differentiate tan, we get sec squared. Okay, we maintain y like that, and then we differentiate y, that will be 1. But each time we differentiate y, we add dy over dx, and that is going to be equal to, now we differentiate x, that is going to give us a 1. So from here we'll see that dy over dx is going to be equal to 1 divided by sec squared y. Now we know that sec y is the opposite for cos, that is 1 over cos y. If I square this one, even this one is going to be squared. And so this is going to give us, where there is 1, we know that 1 is the same as sin squared y plus cos squared y, and then divided by cos squared y. Sin squared over cos squared, that is going to give us tan squared. And then cos squared over cos squared, that is going to give us a 1. So sec squared y is tan squared y plus 1. But what is our tan y? Tan y is equal to x. Therefore, this is going to be 1 over, I'll start with the 1 and then plus, where there is tan squared y, I'll put x squared because tan y itself is squared. So every time we differentiate tan inverse of x, we get 1 divided by 1 plus x squared. Let me look at the last one. And then the others, we can also do them. We can try them out. If we want to find the derivative of y is equal to, let me use sec inverse of x. So if I take sec the other side, that will become sec y is equal to x. So from here now I'm going to find the derivative, d over dx. Now what is the derivative for sec x? Well, sec x, we know that is the same as 1 over cos x. So finding the inverse, the derivative for this one, f prime of x, if this was f of x, that is going to give us, we're going to use the quotient. We get what is down, that is the cos x. We differentiate what is on top. So let me write here f prime of x. So we're saying we get what is down, that is the cos x. We differentiate what is on top, 1, that will give us a 0. Minus, we get what is on top, that is the 1. Differentiate what is down, that will give us negative sin of x. And then divide by what is down squared, that will be cos squared x. And this will give us, this is a 0, this is going to become a positive sin. That will be sin x divided by, now cos squared is the same as cos x and then cos x. So sin over cos, that is going to give us tan. And then we've got a tan cos which has remained down. If we take it on top, it gives us sec. So every time we differentiate sec, we get tan x sec x. But this is sec y. So if we differentiate sec, we are going to get tan. But we are talking about y. Okay, we're talking about y. Tan y and then sec y. So we just differentiated sec. And then go on and differentiate y. That is going to give us a 1. But every time we differentiate y, we add dy over dx. And that is going to be equal to, the derivative for x is a 1. So to remain with dy over dx, we divide both sides by tan y and then sec y. And from here, what is our sec y? Sec y is x. So we're going to substitute. So this is going to be 1 over, I'll start with x. But what is our tan y? Well, we know our identities, and we already showed that area where we said sec squared y is the same as tan squared y plus a 1. So where there is tan squared, I can as well make tan sub the formula. So that would be tan squared y is equal to sec squared y minus 1. I'll take 1 the other side. So remain with tan y, I'll square root both sides. So that is going to be, where there was tan y, I'll put the square root of sec squared. But what is sec? Sec is x. And this, because we're talking of sec squared, I'm going to square the x. So that will be x squared minus a 1. So every time we differentiate sec inverse of x, this is what we get. But always this x we are using should be positive, so we put it in absolute bars. So that is how we get to do that. Now let's look at some just examples on how to apply this. Find the derivative of y, which is equal to sin inverse of x. Well, how are we able to do this one? So dy over dx is going to be equal to, first we're going to differentiate the sine inverse, and we saw that when we differentiate sine inverse, what we get is 1 divided by the square root of 1 minus, for that one which we are doing there was x here, but since there's root x, I'm going to put root x. So it was x squared, so this is root x squared. If we are done with differentiating sin inverse, now we're going to multiply. We differentiate the root x. Root x is the same as x to the power 1 over 2. So we first multiply the 1 over 2 by the function and then subtract a 1, negative 1 over 2, like that. So this is going to give us 1 divided by, well, this 2 is down the fraction, so you can also write it down there. This x is raised to a negative power, so we can also take it down. It becomes x to the power positive 1 over 2, but 1 over 2 is the same as root, so I can write it like that. And then we also have another root down there, 1 minus, or the root of x squared, that will just be x. I can as well write this as 1 divided by 2 and then root. So I'll multiply this x with what is inside there, so that will be x minus x squared. Now differentiate y is equal to tan inverse of x to the power 3 plus x. The same dy over dx is going to be equal to the derivative for tan inverse. We saw that that is 1 divided by 1 plus, there was x here, x squared, but in this case x is x to the power 3 plus x. So this is what we are going to square after we finish that, and then we are going to multiply by the derivative of this part, and that is going to give us 3x squared plus a 1. Therefore the derivative is 3x squared plus 1 divided by, we'll just expand the brackets down there, and that is going to give us x to the power 6 plus 2x to the power 4, and then plus x to the power 2. So that is how it's going to become. Alright, let's look at another one. Y is equal to cosine inverse of 1 minus 2x. We want to find the derivative. So dy over dx is going to be equal to, the first thing is to find the cosine inverse, the derivative of cosine inverse, and you know that the derivative of cosine inverse is negative 1 divided by the square root of 1 minus x squared, but x in this case is this one, that is 1 minus 2x. So we're going to square this. After we are done with that, now we differentiate the angle. That is going to be a negative 2 if we differentiate 1 minus 2x, and so therefore the answer is just going to give us negative times negative, that gives us a positive 2 over the square root. We have got 1 minus, inside we have got 1 minus 2 squared, 1 minus 2x squared. So this, if we expand it, to give us 1 minus 4x and then plus 4x squared. So write this. Now each of this, there is a negative here, so each of this will multiply with a negative, so that will be negative 1, positive 4x, and then negative 4x squared, and this will give us 2 divided by the root of this, and this will cancel out, and we can see a 4x is common on there. I can just factorize out a 4 because I know it's a perfect square, and we'll remain with x minus x squared. Now the root of 4 is a 2, so that is going to give us 2 divided by 2 and then square root of x minus x squared, and this 2 and that cancels, so that will just give us 1 divided by the root of x minus x squared. And the last question here, find dy over dx of y is equal to tan inverse of x cubed. So how do we go about it? Well, dy over dx is going to be equal to, so firstly we are going to get tan inverse of x to the power 3, I mean the derivative of tan inverse. And the derivative of tan inverse, we know that that is 1 divided by 1 plus whatsoever the value of x here, we square it. And then times, now we get this angle, we find the derivative, that will be 3x squared. And so this is going to give us 3x squared divided by 1 plus x to the power 6. So that is going to be it. Well, perhaps if we had something, this is just a page I want to use. We're not talking about limits anyway. Now, if we had something like y, let's say 2y plus tan inverse of x is equal to, let's say, 3. How would you have gone about this one? Let me even add x here. So such would have been an implicity. So the first thing to find the derivative, this would be d over dx. I'm first going to factorize out 2 because it's a constant, but because we've got a product, I'm going to maintain y, differentiate x. If I differentiate x, that is going to give us what? A 1. After we are done with that, and I'm going to maintain x the way it is, and then differentiate y, that will give us also a 1. But every time we differentiate y, we add dy over dx. And then plus, find the derivative for tan inverse. We know that is 1 divided by 1 plus whatsoever the angle here, that is x, we square it. And then that is going to be equal to make just the question more interesting, let me put y squared. So we're going to differentiate 3y squared. That is going to give us 6y. Every time we differentiate y, we add dy over dx. So I'm going to distribute these two. That is going to be 2y plus, there's x here, multiplied by 2, that will be 2x, and then dy over dx plus 1 divided by 1 plus x squared is equal to 6y dy over dx. I'm going to take to one side everything that has got dy in them, so I'm going to take this one the other side. This will remain 2y plus 1 divided by 1 plus x squared is equal to 6y dy over dx minus 2x dy over dx. I can say this is over 1 and make this as a single fraction, so multiply this and this. That is going to be 2y 1 plus x squared, multiply this and that is going to be y, and then multiply the two denominators, that will just be 1 plus x squared, and that will be equal to factorize out dy over dx. So I'm going to remain with 6y minus 2x. Now at this point we can remain with dy over dx. So dy over dx is going to be equal to, I can distribute 2y, that will be 2y plus 2y x squared and then plus a1 divided by 1 plus x squared, and I'm also dividing by this one, so this will be 6y minus 2x. So this is going to be the derivative. Thank you so much for watching. Stay blessed.